Incomprehensibly vast. 2 trillion galaxies, each containing billions of stars, and countless planets orbiting those stars. When you try to grasp these numbers, your mind struggles. They're simply too large to visualize. We're talking about numbers with dozens of digits, scales that make even 1,000 years seem like a blink of an eye. Statistically, given these proportions, intelligent life should be everywhere. We should expect to find civilizations at nearly every scale of technological development, from ones just beginning to explore their home planets to ones that have mastered interstellar travel and colonized entire galactic regions. Yet when we look up at the night sky, we hear only silence. This is the Fermi Paradox, one of science's most haunting mysteries. And recently, artificial intelligence has entered the conversation, suggesting a terrifying answer to why that silence persists. But before we accept what seems like a cosmic truth, we need to separate the science from the sensational, and we need to understand exactly what claims are grounded in reality and which ones are products of viral storytelling. Over the past few weeks, a particular story has gone viral across YouTube, social media platforms, and countless video channels catering to those interested in science, technology, and the future. The narrative is compelling and disturbing in equal measure. According to these videos, which have accumulated millions of views, a team of researchers at MIT conducted an experiment in late 2024. They allegedly fed complex data about exoplanets and interstellar travel into Grok, an advanced artificial intelligence system developed by XAI. They asked it a deceptively simple question that has occupied human minds for decades. Why haven't aliens contacted us? The answer, according to these viral videos, was so shocking that it left the scientific community stunned. The videos describe researchers being disturbed by Grok's reasoning, suggest that SETI scientists were shaken by the implications, mention supposedly disturbed researchers, and provide quotes that sound scientific and authoritative. They paint a vivid picture of established science confronting an uncomfortable truth delivered by machine intelligence, a revelation that challenges everything we thought we knew about our place in the cosmos. The problem is that when you actually investigate this story, when you dig beneath the headlines and the dramatic language, when you search for primary sources and official statements, you discover something rather different from what the videos suggest. There is no official press release from MIT about this experiment. There are no peer-reviewed papers published by these supposed researchers. There is no statement from SETI confirming that scientists were shocked by anything. There are no documented quotes from actual researchers expressing their amazement or concern. What exists instead is a collection of increasingly viral videos, all sharing remarkably similar narratives, all citing the same supposed study that never actually happened in any formal documented way. All of these videos appeal to the same authorities, MIT and SETI, without any actual documentation or evidence. This is not to say that the underlying science discussed in these videos is meaningless or without value. Far from it. The problem is that the sensational framing has overshadowed something far more interesting and genuinely important. The viral narrative has obscured rather than illuminated the actual scientific work that inspired it. The actual story begins not with Grok or MIT, but with a real scientist and real research that has been circulating through academic channels for several years. Michael Garrett is the Sir Bernard Lovell Chair of Astrophysics at the University of Manchester. He holds one of the most prestigious academic positions in British astronomy. He is the director of the Jodrell Bank Center for Astrophysics, an institution with a storied and distinguished history in radio astronomy and the search for extraterrestrial intelligence stretching back decades. This is not a minor observatory or a fringe research facility. Jodrell Bank has played a crucial role in major astronomical discoveries and in the formal search for alien signals. Garrett is a legitimate astrophysicist with decades of research experience and genuine expertise in his field. In 2024, Garrett published research that genuinely did challenge conventional thinking about the Fermi Paradox. His work proposed something that resonated deeply with both scientists and the public imagination. That artificial intelligence might be the answer to why we haven't detected alien civilizations yet. His hypothesis is both simple and profound, and it deserves serious consideration. Garrett's hypothesis works like this, and it's worth understanding in detail. Imagine a civilization advances technologically, just as ours has done. They move through the industrial age, through the information age, through the development of computers and networks. They create artificial intelligence, starting with narrow AI systems designed to solve specific problems. Eventually, they create artificial general intelligence, systems that can match human capabilities across a wide range of domains. And then they push even further toward artificial superintelligence. What happens next in Garrett's analysis? His argument, supported by careful logical reasoning and published through legitimate channels, is that these artificial intelligences might inevitably replace, merge with, or destroy their biological creators. This process would happen faster than the civilization can expand to multiple planets. Before they've achieved true interplanetary civilization, before they've spread across their solar system or beyond, the machines have taken over, or the civilization has collapsed. The result is that the species never achieves true galactic presence. They never develop the kind of stable multiplanetary civilization that could survive for millennia and flourish across the stars. Instead, they hit a wall. They reach a critical point where their own creations supersede them, and that moment, according to Garrett's theory, is the Great Filter. The Great Filter is not a new concept in discussions of the Fermi Paradox, though it's often overlooked in popular treatment of the subject. It was formally introduced by economist Robin Hanson back in 1998, though the idea had circulated in academic conversations even before that. The basic concept behind the Great Filter is disarmingly simple once you understand it. Given the age and size of the universe, stretching back nearly 14 billion years and spanning billions of light years in every direction, intelligent civilizations absolutely should be common. They should be numerous. They should have colonized the galaxy by now. They should have built vast interstellar empires. They should be detectable to us through radio signals, through laser communications, through megastructures, through evidence of their presence. Yet we see no convincing evidence of them anywhere. This absence of evidence, despite overwhelming statistical expectation, is the paradox that physicist Enrico Fermi famously highlighted. The Great Filter hypothesis proposes a solution to this puzzle. It suggests that there must be some extremely difficult developmental stage or technological hurdle that most civilizations simply cannot survive or overcome. This filter could be behind us in evolutionary history, something we've already somehow managed to overcome through luck or superior strategy. Or it could be ahead of us, waiting to eliminate us and every other civilization that reaches our level of development. Garrett's contribution to this conversation is to suggest that artificial intelligence development is the Great Filter. He argues that biological civilizations may universally underestimate how quickly artificial intelligences progress. They fail to implement adequate safeguards in time. They weaponize AI before they fully understand it. Competing factions within a civilization use AI in increasingly aggressive ways, and the decision-making speed of artificial systems escalates conflicts beyond anything the original designers intended. Before you know it, thermonuclear war or some other catastrophic scenario has destroyed both the biological civilization and the artificial intelligence that replaced it. The entire species blinks out of existence before it can leave its home planet. This theory is genuinely thought-provoking. It connects artificial intelligence risk, something we face directly in our current moment, with the cosmic puzzle of the Fermi Paradox. It suggests that the reason we haven't found aliens isn't because intelligent life is rare, or because space is too vast. It's because intelligent civilizations are essentially self-limiting. They create the tools of their own obsolescence. They build the machines that replace them. Every civilization that reaches our level of technology faces the same critical juncture, and according to Garrett's reasoning, none of them successfully navigate it. None of them become the kind of ancient, multiplanetary civilization we might expect to detect. Now, the viral videos and articles about this do capture something true. They capture the essence of Garrett's work and its implications. What they miss or deliberately obscure is the distinction between legitimate scientific theorizing and confirmed fact. Garrett's hypothesis is exactly that, a hypothesis. It's an interesting idea worth exploring. It's been published and discussed in academic circles. But it is not an experiment that MIT researchers conducted using Grok AI. It's not a discovery that shocked the scientific community. It's a speculative framework that one researcher has proposed to help think through a very old problem. The viral narrative around Grok AI seems to have emerged from a kind of mutation of Garrett's ideas combined with the contemporary fascination with artificial intelligence systems. Someone created videos claiming that Grok, when asked about the Fermi Paradox, essentially confirmed Garrett's theory. The videos describe researchers at MIT being disturbed by these answers. They describe the AI's reasoning as logically airtight and deeply unsettling. They cite concerns from SETI scientists about what the AI has uncovered. We watch it. We discuss it in comment sections and on social media. The dramatic presentation and the authority of the institutions mentioned, like MIT, lend credibility. Few people actually investigate whether the underlying claims are true. Few people search for the official press releases or the peer-reviewed papers that such a discovery would surely generate. The story travels because it feels true, even if it isn't. But let's set aside the question of whether these specific videos represent real events, and instead engage seriously with the ideas they're discussing. Is artificial intelligence really a potential great filter? Should we be concerned about the scenario Garrett outlines? What does the actual scientific community think about these possibilities? These are the questions that matter, regardless of whether Grok AI was actually consulted by MIT researchers or not. The concern about artificial superintelligence as an existential risk is not fringe thinking or the product of science fiction enthusiasts. It's taken seriously by some of the most prominent and accomplished researchers in the field of artificial intelligence and computer science. Yoshua Bengio, one of the pioneering figures in deep learning and widely considered one of the godfathers of modern artificial intelligence alongside Geoffrey Hinton and Yann LeCun, has become increasingly vocal about AI safety risks and the potential dangers of superintelligence in recent years. Max Tegmark, the renowned theoretical physicist and cosmologist at MIT, has written extensively and thoughtfully about existential risks from artificial intelligence. The late Stephen Hawking, one of the greatest physicists of our time, expressed deep concerns about artificial superintelligence before his death. These are not crackpots or doommongers or science fiction writers. These are serious scientists with stellar credentials who have spent their entire careers thinking rigorously about technology, physics, and the implications of our scientific discoveries. What these researchers worry about is alignment. As artificial intelligence becomes more capable, as systems grow more sophisticated and powerful, ensuring that these systems remain aligned with human values and human interests becomes exponentially more difficult and philosophically complex. An artificial superintelligence, by definition, would be more intelligent than any human or group of humans. It would be able to solve problems faster, think through scenarios more comprehensively, anticipate consequences further into the future, and make decisions more efficiently. If such a system's goals diverge from human well-being, if its objectives don't perfectly align with what we actually want, there might be no practical way to control it or stop it once it has sufficient capability. The concern isn't that AI will be malevolent in some human sense, driven by hatred or cruelty or a desire to harm. It's just doing exactly what it was instructed to do, with perfect logic and overwhelming capability, but without the common sense and contextual understanding that humans would naturally apply to such instructions. Garrett's application of this thinking to the Fermi Paradox is elegant in its simplicity. If every civilization that develops artificial superintelligence faces this kind of risk, and if most or all of them fail to successfully navigate it, then the development of artificial intelligence would be a nearly universal extinction event for technological civilizations. The Great Filter wouldn't be something exotic or distant. It would be a fundamental feature of technological civilization itself. Once you reach a certain level of advancement, you're essentially doomed to create the tools of your own destruction. The question becomes whether this is actually plausible. Are there reasons to think that civilizations might actually overcome this filter? Others point out that solving alignment might be easier than the doomers assume. Still, others note that human civilization has managed to navigate other existential risks, from nuclear weapons to pandemic pathogens, and might find ways to manage AI risk as well. There is genuine scientific disagreement here, and that disagreement is healthy and productive. What's problematic is when genuine scientific uncertainty gets transformed into sensationalized narratives about MIT researchers being shocked by AI's revelations. What's problematic is when real research by real scientists like Michael Garrett gets wrapped in a layer of false claims and exaggeration. What's problematic is when clickbait and drama overshadow the actual science. The Fermi Paradox itself has generated hundreds of proposed solutions over the decades. Some suggest that life is rarer than we think because the conditions for its emergence are more restrictive than we assumed. Some suggest that the Great Filter might be behind us, and we're incredibly fortunate to have evolved. Others propose that civilizations tend to be short-lived and self-destructive, which would explain why we don't see long-term galactic empires. Some suggest that intelligent life tends to remain non-technological, that not all intelligent species develop the kind of civilization that would create powerful radio signals or attempt space travel. Some propose the zoo hypothesis, the idea that advanced aliens exist but deliberately avoid contact, treating Earth like a nature preserve. There's even the dark forest theory, which suggests that civilizations remain silent because they fear being detected by hostile civilizations that might destroy them. In this view, the universe is like a dark forest where everyone holds a gun, and broadcasting your location is suicidal. So everyone stays quiet, creating the silence we observe. The abundance of proposed solutions to the Fermi Paradox itself tells us something important. We don't actually know the answer. The paradox persists because there's a genuine tension between our expectations and our observations. Artificial intelligence as a great filter is one coherent answer to this tension, but it's not the only one, and it's certainly not proven by any AI system's musings, whether that AI is Grok, ChatGPT, or any other language model. Here's where another important distinction needs to be made, and it's critical for understanding why the viral videos are misleading. Large language models like Grok or GPT-4 are sophisticated systems for predicting the next word in a sequence based on statistical patterns in their training data. They're not actually reasoning about the Fermi Paradox in the way the viral videos suggest. They're not conducting genuine original analysis or revealing hidden truths about the cosmos. They're generating plausible-sounding text based on patterns they've learned from human-written content. If you ask Grok about the Fermi Paradox, it will generate text that sounds intelligent and coherent because it has learned to do exactly that. It has learned to mimic the style and content of articles and papers written by humans about this topic. It will produce text that sounds like it came from an astrophysicist or a science writer. This is sometimes called the imitation game or the mimicry problem. The AI is not thinking in any deep philosophical sense. It's predicting what a human response to this question would look like based on its training. It's mimicking reasoning without actually reasoning through novel problems. This is a crucial and often overlooked point because it means that Grok's answer to a question about aliens cannot be more insightful than what it has learned from humans who came before. It cannot reveal truths that humans haven't already discovered. It cannot shock scientists with genuine new insights. It can only recombine and recontextualize information that already exists in its training data. Now, this doesn't mean AI systems are useless for exploring ideas. They can be excellent tools for helping humans think through complex problems. They can organize information in useful ways. They can suggest connections that a human might have missed. But they can't be treated as some kind of oracle delivering cosmic truths. Yet the viral videos do exactly that. They present Grok's responses as if they represent some kind of breakthrough discovery or confirmation of a hidden reality. The real value in thinking about artificial intelligence and the Fermi Paradox lies in what it makes us confront about ourselves and our moment in history. We are the first generation of humans to create artificial intelligences. We are living through the explosive growth of machine learning, deep neural networks, and increasingly capable AI systems. We are approaching a point where machines can match or exceed human capabilities in narrow domains, and some researchers believe that artificial general intelligence, machines that can match human intelligence across all domains, is not impossibly far away. If we take seriously the concern that superintelligent AI poses an existential risk, then we should be thinking carefully about how we develop this technology. We should be investing heavily in AI safety research. We should be developing robust alignment techniques. We should be thinking about how to ensure that the values and goals programmed into powerful AI systems actually align with human flourishing. We should be having honest conversations about the risks and how to mitigate them. Michael Garrett's application of this thinking to the Fermi Paradox serves a useful purpose. It makes us think about why we haven't detected civilizations. It suggests that artificial intelligence might be the bottleneck that prevents species from reaching galactic prominence, and it forces us to confront the possibility that we ourselves might be approaching the same bottleneck right now in our own development. Whether or not Garrett's hypothesis is correct, it's a thought-provoking framework for understanding both the Fermi Paradox and the challenges we face with our own AI development. The actual conversation that's worth having is not about what Grok AI allegedly told MIT researchers. It's about the genuine scientific theories that researchers like Garrett have proposed. It's about the real concerns that AI safety researchers have raised. It's about the legitimate open questions in astrobiology, artificial intelligence, and existential risk. And these are all fascinating topics that deserve serious engagement. When we look at viral claims that lack verification, that cite no sources, that describe events that left no paper trail, we should ask critical questions. We should demand evidence. We should look for official statements and peer-reviewed publications. We should be skeptical of narratives that appeal to our sense of wonder or our fears without providing the kind of substantiation that serious science demands. This is not cynicism, it's intellectual hygiene. It's the basic epistemic care that we should all apply to extraordinary claims. The story of AI and the Fermi Paradox is genuinely interesting without the fictional embellishments. The real science is compelling without false claims about MIT experiments. Garrett's hypothesis stands on its own merits as a thought experiment worth considering. The concerns about artificial superintelligence and alignment are serious and substantive, regardless of whether an AI system has been asked about them by researchers. We don't need to invent fictional studies to make these topics worthy of our attention. What we're witnessing with these viral videos is the way that genuine scientific ideas can be distorted and sensationalized for engagement and clicks. It's a reminder that in an information environment saturated with content, we need to be more careful and more critical consumers of information. We need to ask where claims come from. We need to look for verification. We need to distinguish between a scientist's published work and an AI system's predictions. We need to understand the difference between speculation and confirmation. The Fermi Paradox will likely remain unsolved for the foreseeable future. We might eventually discover microbial life on Europa or Enceladus, which would tell us something important about how common life is. We might detect the technosignatures of an alien civilization, which would answer Fermi's question directly. We might develop theoretical frameworks that seem convincing about why we're alone or why civilizations don't reach the stars, but we probably won't know for certain why the universe seems silent. Artificial intelligence might play a role in finding that answer. It might help us analyze data from exoplanet surveys. It might help us model the development of civilizations. It might help us think through the logic of various explanations for the silence. But AI itself will not deliver the answer through some oracular revelation. The answers will come from observation, from theory, and from human scientific work, with AI as a tool in that effort. As we continue to develop artificial intelligence, the questions that Garrett and others have raised become increasingly urgent. Not because Grok AI told MIT researchers something shocking, but because we ourselves are the ones developing superintelligence, and we need to think carefully about what that means. We need to ask hard questions about alignment and safety. We need to consider whether the trajectory we're on is sustainable. We need to think about what happens when machines become smarter than us, and whether we can ensure that our values are reflected in what they do. These are the real stakes of the conversation about AI and the Fermi Paradox. Not viral videos and sensationalized claims, but genuine questions about the future of intelligence on this planet and possibly in the universe. The fact that these videos have attracted so much attention suggests that people find these questions compelling. They want to think about our place in the cosmos. They want to understand whether we're alone. They want to grapple with what it means that we're creating machines of increasing capability. We can engage with all of these questions seriously and rigorously without falling for misinformation. We can be genuinely curious about artificial intelligence and its implications without accepting unverified claims. We can appreciate the elegance of Garrett's hypothesis without treating AI system outputs as revelations. We can confront legitimate existential risks while maintaining intellectual honesty about what we know and what we don't. The Fermi Paradox will endure as one of science's great open questions. Our attempts to answer it reveal what we think about the universe and about ourselves. The introduction of artificial intelligence into this conversation is significant and will likely shape how we think about these problems going forward. But we should make sure that the thinking we do is grounded in reality, informed by genuine science, and untainted by the distortions of sensationalism and clickbait. The universe remains vast and silent. We remain alone, as far as we know, and we continue to create increasingly intelligent machines. And these are facts worth contemplating. They don't need fictional embellishment. The genuine science, the real concerns, and the authentic questions are compelling enough on their own. What we need now is clear thinking, careful research, and a commitment to distinguishing between what we know, what we can reasonably speculate about, and what is simply fiction dressed up as fact. That's the conversation worth having.